Hi math students, and welcome to the start of Unit 3. So at this point you are officially halfway through all the material, which is very exciting. Unit 3 is going to focus on fractions and decimals, everyone's favorite thing. And we are going to start off this first lesson on just an introduction to fractions. Before we get into that, since we are halfway through the material, I'm going to start including just a few review questions at the start of each of these. I think it's very easy with the amounts of stuff we learn in this class and the speed we move through this class to learn something 2 weeks ago. And since you've learned so much between 2 weeks ago and today to have forgotten what you've learned 2 weeks ago, there is a final at the end of the class. So to help make sure you remember everything you've already learned, I'm going to start including some of these review questions, which is something we would do in person in class as well. So the ones for today, the first one is, what is the difference of 327? To answer that, you need to know what difference means. Difference means subtraction. So when we say what's the difference of, we're saying what do you get when you subtract these two numbers. When you subtract 327, you would get 273. The second one says, Keiji, Raho, and Anna found 20 candies and decided to split them equally between them. How many does each person get? Well, there are 20 candies that we're splitting between 3 people, so 20 divided by 3. Well, 3 is going to go into 26 times. That'll get you to 18, and there would be a remainder of 2, so 2 extra candies. Now that you've got those brain juices flowing, we said today is going to be an introduction to fractions. Specifically, what we're looking at today is how to identify a fraction, how to represent something as a fraction, and then how to compare fractions. We've talked about comparing things before. We've used inequality signs, that less than, greater than sign. We're going to do something similar today with fractions. Now, usually when I do this in class, everyone goes, oh my God, fractions. I literally know nothing about fractions. And I usually start off by bringing in some apples to show you that's simply not true. You do know some stuff about fractions just from your everyday life. No, I don't have apples today since there's no one in class to eat them with me. But I do have some pictures of apples. If I was holding this right here, we could say that is one whole apple. If I were to cut that apple like this, if I were to take a knife and cut it just right down the middle, what would each part of that apple be called? Each part would be called a half. When you cut things in the middle like that, you're cutting it in half, is a word you hear a lot outside math class. Now, if I had taken that same apple, it's beautiful. If I took that same apple and I cut it like this, what would you call each of those? Well, you wouldn't call them a half because it's not down the middle like this one. One of the things that we're gonna really want to emphasize when you're talking about fractions is that when you're talking about fractions, it's important that those two parts are equal sizes. It says it's important that they are equal sizes. If you have a fraction, a half, or other fractions, all those parts in your apple or your shape need to be the same size. So something like this would not be a half. Now we've got it, if it's in 2 parts, it's called a half. What if I cut it up into 4 parts? What would each one of those be called? Well, each one of those would be 1/4. This, I think, is like the only fraction where you can read it 2 different ways. You could say this is 1/4. You might also hear 1/4. I'm more accustomed to saying 1/4, but we could say each of those is called 1/4. Okay, I've taken the apple now and I've cut it up into 8 parts. If it's in 8 parts, each one of these would be called 1/8. Now, each one of these would be called 1/8. So if I had this little piece here, that would be 1/8. What if I had that piece and this piece? Well, that would be 1/8, 2/8. If I added in this one, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. So if you're adding them up, notice it's just that first number that's changing each time. This is 1/8. but then that would be 2/8 and so forth. Getting into that idea of counting up, there's in these fractions 2 different numbers we're writing each time, and both of those numbers have names. The number on top is what we call the numerator. That is this number right here. And your numerator is going to tell you how many counted parts. What I mean by counted parts is how many parts you have. So if I was talking about that apple earlier and I had one of those slices, that one is telling me I have one slice. I have 1/8 of the apple. If I had 2 slices, then I would have 2/8. I would have 2/8 of the apple. This number, your numerator, just tells you how many you have. This bottom number here is what we call the denominator. Your denominator is going to be how many parts are in the whole. So before, when I was looking at those pictures of the apple, it was that bottom number, or the denominator, that changed each time when I changed how many parts it was cut up into. Right? When it was in 2 parts, it was 1/2. That denominator was 2 for 2 parts. When it was in 4 parts, it was 1/4. 4 was the denominator to show that it was in 4 parts. It was that denominator that changed each time when we made it into more parts. The other thing to notice is that that denominator there, as that number gets bigger, what is happening to the size of each piece? Let me go back to those pictures one more time. As that denominator got bigger, so as I went down, it was 1/2, 1/4, 1/8. That bottom number was getting bigger. What was happening to the pieces? Well, the pieces were getting smaller, right? Each time, those slices are smaller and smaller because you're cutting it up into more pieces. So we could say here, important, as the denominator gets bigger, the size of each piece gets smaller. That means if I had, let's do something other than an apple. Let's do a pizza. If I had 1/2 of the pizza and you had 1/200th of the pizza, as that denominator gets bigger, the size of the pizza gets smaller. This is very, very small compared to this. You kind of have to change your brain a little bit, right? 200 is bigger than 2, but when it says a fraction, 1/200th is much, much smaller than 1/2. This already is a way for you to start getting a sense of what fractions look like, how big they are. That's going to help us later when we start comparing fractions. Now, I've already been using the word fraction a lot, but when we're talking about fractions, fractions are always a part of something. It's either a part of a whole, like that apple was part, I was using a fraction when it was part of a whole apple, or you can also have it be part of a set. So 2 more examples here. An example of a part of a whole could be a pizza. If you ate 1 of the 4 slices of pizza, we could say you ate 1/4. That is part of a whole pizza, similar to the apple. Another example, though, could be cookies. If I've got 4 cookies in front of me and you ate 1 of the 4 cookies, I could say you ate 1/4 of the cookies. It's not that you ate part of a cookie, you ate the entire cookie, but you ate part of the set of cookies. You ate 1 cookie out of 4 cookies. So there's 2 different ways you could use fractions. To get more experience with writing the actual fractions, we've got a couple examples here. If I wanted to write a fraction to represent what fraction of the rectangle is shaded, there's 2 numbers I need. I need that top number, which we said is that counted number. Your numerator, that top number, is how many you have that would be shaded. Here, that's going to be 1, 2. And then that bottom number, or your denominator, is how many total parts are in that whole. So in this whole rectangle, there are 1, 2, 3, 4, 5 parts. That means my denominator would be 5. So this right here says 2/5 of this rectangle is shaded. Another way you can think of it is it's saying 2 of the 5 parts are shaded. 2 of 5 are shaded in. Go ahead and try this one here for me. What fraction of this circle is shaded in? Well, I see 1, 2, 3. There are 3 parts shaded of 1, 2, 3, 4 total parts. So we can say 3/4 of that circle is shaded in. Got a couple more. This one right here, I've got a pie. And there's 2 questions that go with the pie. The first one is what fraction was eaten? And the second question is what fraction is left? Just in case those lines aren't showing up clearly on camera, I'm gonna make them a little darker. The actual lines are much straighter than mine, but those are where the cuts are in the pie. So what fraction was eaten? Well, if I look, 1 part was eaten out of a total of 1, 2, 3, 4, 5, 6, 7, 8. What fraction's left? There will be 7/8. Now I did that without counting. Do you know how I did that? Well, I already knew there was a total of 8 parts. So if 1 was eaten, notice these 2 numbers here have to add up to the total. 1 plus 7 gives you a total of 8. Every single slice is either an eaten slice or a slice that's left over. So I just said 8 minus 1 gives me 7. There must be 7 left over. Now these are examples of writing fractions of a whole. So all of these, part of the whole thing was eaten or left over. The other fraction, remember, is a fraction if you have part of a set. So here I have a set of animals. And the first question says, what fraction of the animals are cats? Similarly to the other one, there's 2 numbers I need. That numerator here, that top number, is going to be how many of the animals are cats. How many cats do I count? Well, I see 1, 2, 3. So that means my numerator is 3. Your denominator is the total. So this time, instead of how many total parts there are, it's going to be how many total things are in our set. So for this problem, that's 1, 2, 3, 4, 5, 6, 7, 8. So we're left with 3/8 of the animals are cats. There are 3 cats out of 8 animals. You go ahead and try this next one. What fraction of the animals are dogs? For this one, there are 5 dogs out of a total of 8 animals. So these are all examples of how you write fractions. Now the next part to this is going to be how you can represent a fraction. So the directions here say draw the fraction. If I've got the fraction 2/5, there are a couple ways you can do this. One way is by drawing a fraction of a whole, kind of like those first problems. I could draw a shape and then show that I've got 2 of the 5 parts of the shape shaded, usually is how we do it. Now there's something I want to remind you with this. Remember way back at the beginning, we said with this apple that it's important that they're equal sizes. So when you go to draw your fraction, notice here each part is the same size. Each part is the same size. It's not like they did something like this, where there's 4 parts but they're all different sizes. You can't do that. They all have to be equal. So for students and for me, usually the easiest shape to draw that is all equal sizes is going to be a rectangle. If I want to draw a rectangle with 5 parts, I can go ahead and just draw a rectangle and then make it in 5 parts. And the reason a rectangle is easy to do is if I don't get to 5, so here I've got 4 equal squares and I need a 5th one. Rectangles, you can just go ahead and add another part on. If I tried doing something like a circle is going to be really hard getting them all the same size. Like that's maybe okay, but it could be better. Rectangles are the easiest one to do. So I've got a rectangle. It's in 5 parts because my denominator is 5. If I want to show 2/5, there's still something else I need to do. to show that I have 2/5 of a rectangle, I would want to color in 2 of those 5 parts. So that is an example of 2/5. I've got part of the whole rectangle. Now remember, there's another way you could write a fraction. You could have a fraction of a set. So a different way you could do this, if you want to show 2/5, is you could draw 5 of something and then show that you've got 2 of those 5 things in the set. So thinking back to the cookies, 1/4 of the cookies would be 1 cookie out of the 4 cookies. We could do something like that. Oops, going the wrong way. So another way I could do it is maybe I've got a set of 5 stars. So here's a star, 1, 4, 5. So there's 5 stars. I want to show that 2 of my set are shaded in. So I could also come in and do something like that. And there. Oh yeah, so beautiful. That's another way you could show it, right? 2 out of the 5 stars are shaded in. That's 2/5. Go ahead, and there's this one for you to draw, 5/8. And I got one last one here. Martin orders a pizza and eats 1/3 of the pizza. Draw a picture to represent what fraction of the pizza is left. Now, obviously you can't draw a picture for me, so go ahead and describe what you would do to draw a picture of this. Now this one you have to read very carefully. It says draw a picture to represent what fraction of the pizza is left. It tells me he eats 1/3 of a pizza. That means he ate 1 out of the 3 parts, or probably 3 slices of pizza. So if he eats 1 out of the 3 slices, that means what's left over? 2 out of the 3 slices, 2/3. So we want to draw a picture of 2/3. Since we're talking about pizza, I would probably do my best to draw something that looks like a pizza. And 3 slices would look kind of like that, a little bit. So to draw 2/3, I would just want to color in 2 of the 3 parts. That one can be a little tricky if you're not reading carefully. Now the next part to go with writing fractions, representing fractions with pictures, is some fraction word problems. So we've got this first one to look at. They're all going to have to do with Crystal and Edith are visiting the pet store. So the first one says, they see 15 goldfish in the aquarium. 4 of the goldfish are orange and 11 of them are silver in color. What fraction of the fish are silver? So we are trying to answer the question, what fraction of the fish are silver? Just like our other problems, there's going to be 2 numbers I need to find to write my fraction. I'm going to start for this problem with that bottom number. Remember, that bottom number is always your total. Maybe the total parts in your whole, the total number in the set. Here, what is the total? Here the total is those 15 goldfish. Now remember, that top part is the part that's counted. It's how many you have, how many that you're looking at here. The question is asking what fraction of the fish are silver. What number would go up here? Well, we want to know how many are silver. It tells us 11 of them are silver. So I could go ahead and say 11/15. It means there are 11 silver out of 15 total fish. So that would be our fraction there. Because it's a word problem, I might put some more words in. So we could say 11/15 of the fish are silver. Go ahead and try this next one. It says there are 9 packs of pet food on the shelf. 5 of them are for cats and the rest of them are for dogs. What fraction of the food is for dogs? All right. For your denominator, that total here, there's a total of 9 packs. For the numerator, or that counted part, it wants how much of the food is for dogs, but they didn't tell us that. They told us 5 are for cats, and they just said the rest of them are for dogs, which means you had to do some math. There's a total of 9. If 5 are for cats, I can subtract to figure out that that means there must be 4 for dogs. So we would want to say 4/9. 4/9 of the food is for dogs. Now this was the first part, which was all about writing fractions, representing fractions. The last part of this lesson has to do with comparing fractions. When you compare fractions, remember when I say compare fractions, I'm talking about like which one's larger, which one's smaller. There are a couple strategies you can use to help you compare them. The first one is something we already said at the beginning of this lesson. Remember when we were talking about the apple and cutting up the apple, one of the things that students notice is that that denominator of the fraction gets bigger. The denominator is the bottom number. So the denominator gets bigger. We said the size of the fraction gets smaller. So just by knowing that, those fractions we had written with the apple, 1/2, 1/4, and then there was a 1/8 at the end. Just by knowing this fact, that helps me know, well, 1/8 must be smaller than 1/2. The denominator is bigger. That means there's more pieces. That would tell me, well, if I have 1 out of 8 slices of apple, that's not as much as having 1 out of the 2 slices of apple. So that's one way you can help yourself figure out which one's larger, which one's smaller. The second one is going to be to use a model. Model is just a fancy math word for drawing. So you could draw a picture of the fractions and use that picture to help you compare. Now, when you're drawing fractions, there's something that's really important you do. It's to make sure the size of the whole is the same. What I mean by that is, if I wanted to draw 2 pictures to help me figure out which one's bigger, 1/2 or 1/4, if I'm using a circle for my picture, I need to make sure the circle is the same size for both fractions. I'm going to draw 1/2. The circle for 1/2 needs to be the same size as the circle for 1/4. That's what we mean by the size of the whole is the same. There's one last strategy you can use to help you compare fractions, and that is this idea of compare fractions to the one fraction everyone is okay at visualizing, 1/2. You might not immediately have a picture in your head of what 3/12 looks like, but most people can picture what a half looks like. It's just splitting something right down the middle and having half of it. So if you can compare a fraction to 1/2 and know that it's bigger or smaller than 1/2, that can start to give you an idea of how big or small different fractions are. So I'm going to do 2 examples, and I'm going to kind of use these different strategies to help us compare fractions. The first example we're going to look at is this question here: which is bigger, 1/4 or 1/2? One of the strategies we said is look at the denominators. So one of these fractions has a denominator of 4, and one of them has a denominator of 2. Notice that the numerators are the same. So for both of them, I just have one part of it. But here I have 1 out of the 2 parts. Here I've got 1 out of the 4 parts. Usually if you're trying to visualize this, the easiest one students like to use is pizza. If you ate half of a pizza and I ate 1/4 of a pizza, well, this means you ate 1 of the 2 slices. I ate 1 out of the 4 slices. Just by knowing that a bigger denominator means the pieces are smaller helps you get an idea of the size of those. Another strategy we said you could use is pictures. So I could draw 2 pictures. I could draw a picture of 1/2 and a picture of 1/4. If I went to draw 1/4, I'm going to use a square to draw it. So here's my square, and I'm going to divide my square into 4 parts. 1/4 means you have 1 of those 4 parts, so I'll color 1/4. And then I'll draw a picture of 1/2. I could use which one is shaded more to help me determine that that fraction is bigger. When I draw 1/2, remember the size of the whole needs to be the same. So that means here, notice that that box I drew is this big. When I draw it for 1/2, it has to be the same size. So I can't draw like a little tiny box like this and then use it to compare them. to the best of my ability, I'm going to draw a box that is the same size. And then this time I want to show 1/2. So that would be splitting it into 2 parts and then saying I have one of the 2 parts. Now the way you use the model or your pictures is if there's more shaded, that means there's more of it. It means it's the bigger fraction. So you could also look at these 2 pictures and use that to help you figure out which one is bigger. Now the last way is comparing them to 1/2. Now this one here, we have 1/2 already. So 1/2 is 1/2, it's equal. But I could compare this other fraction and just kind of thinking about what I know about fractions, what they look like, in my head say, okay, well, is this more or less than 1/2? And then use that to help me figure out which one is bigger. We've kind of talked through all 3 strategies. Go ahead and tell me which one is bigger, 1/4 or 1/2. All right. I think especially if you've got the picture in front of you, it's easier to see 1/2 is bigger because there is more shaded in 1/2 than 1/4. So my final answer would be 1/2 is the larger fraction. I could also ask you to use an inequality. We could say 1/4 is less than 1/2 by using that inequality sign there. There's one other one. We've got Brian ran 4/5 of a mile and Abdullah ran 3/10 of a mile. Who ran further? Go ahead and try this one before we talk through it. All right. I think the 2 best strategies to use to help you compare, well, the first one could be comparing both of them to a half. So 4/5 of a mile. It means if you divided up a mile into 5 parts, you ran 4 of those 5 parts. I'm going to kind of use a line, I think, to show this fraction. So if I were to say this is a mile and I divide it into 5ths, let me do my best. 1, 2, 3. Oh, that's pretty good. That's 5ths. You can also think of it as just like a long rectangle. So here's my mile and he ran 4/5 of it. If I compare that to a half in my head, I already know he ran over half of a mile. 4 out of 5 parts, you're almost close to being done with that mile. So I know this one is more than a half. Now before I do my drawing, 3/10 of a mile, if you divide that mile up into 10 parts and you run 3 of those 10 parts, well, that's not a half yet. This one here I know is less than a half. So right away, just by comparing both of them to half, I know this one's more than a half. I know this one's less than a half. That's going to tell me which fraction is bigger and who ran further. Now, if I finish up my drawing, remember, if I want to draw 3/10, I have to draw it the same size. So I need to draw another rectangle that's the same size, but this time I need to divide it into 10ths. I'm going to do my best to get it equal sizes. So 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in 10 mostly equal parts. If he ran 3/10, that means he ran 3 of those 10 parts. So this is a little visual of how far he ran. Once you've got the model or those 2 pictures, it's a lot easier to see Brian must have ran further. He ran 4/5. Abdullah only ran 3/10. So I could say who ran further? It must have been Brian. These were my 2 examples. I've got ones for you to try now. Let me erase all of this. The first question is, which is bigger, 2/3 or 2/2? All right. 2/3 means you've got something in 3 parts and you have got 2 of those 3 parts. 2/2 is it's in 2 parts and you've got both of those parts. 2/2 is just a weird way of saying you've got the whole thing. If I ate 2 out of 2 slices of pizza, that is me eating the entire pizza. So here, which is bigger, definitely 2 halves because it's the entire shape or whatever you chose to draw. The other one says a recipe for cookies requires 3/4 a cup of sugar. You have 1/2 a cup of sugar in your kitchen. Do you have enough sugar? How do you know? There is one last one. Which fraction below is smaller than 2/4? There are 4 options. For this problem, there is only one fraction that is smaller. So you are on the hunt to figure out which one. All right. So right away, I think I would try eliminating some options by figuring out which ones are greater than 1/2. So going through, I know 1/2 is 1/2. 2/3, if I ate 2 out of 3 slices of pizza, that definitely means I ate more than 1/2. So this one's larger than this one. It means it's definitely not going to be the smallest one here. 3/10, I'm thinking about pizza, I must be hungry. If I ate 3 slices out of a total of 10 slices of pizza, this is kind of like the mile we did earlier. That's not quite 1/2 yet. So, whoops, sorry. So I'm not going to eliminate this one because I know it is a smaller fraction. It's smaller than 1/2, so it could be smaller than this one. 8/9. If I ate 8 slices out of a total of 9 slices of pizza, I ate a lot of pizza. I almost ate the entire pizza. It means there's only 1 slice left. So this is a really big fraction. It's definitely not going to be the smallest one here. So by comparing them to 1/2, that's helped me out. Now my task is to figure out which of these two is going to be smaller than 2/4. Maybe switching over and drawing some pictures would be helpful. My 2/4 is I'm gonna draw rectangles. Could look something like this. I've got it in 2 parts, 3, 4 parts now. So 2/4 would be 1, 2 of them. 1/2, 1/2. I remember I have to draw the same size rectangle. And then right down the middle, 1/2. 1/2 and 2/4, I don't know about you, but those look pretty similar. If you're thinking that at home too, keep this in the back of your head because this is going to be something we talk about in tomorrow's lesson. I've got one last one though, 3/10. Oh boy, okay, so I need to draw a rectangle the same size as those, and I'll put it into 10 parts. So I'm going to do my best. Got 2. Okay, 1, 2, 3, 4, 5. All right, 6, 7, 8, 9, 10. It's pretty good. And I've got 3 of them. And now using that picture to help me out, I can see which fraction below is smaller than 2/4. We already knew these were greater than 1/2, so they would have had more shaded in than the 2/4. 2/4 and 1/2 are the same, but 3/10 is smaller. So of all of these, the one that's smaller than 2/4 would be C, the fraction 3/10. This is the last one I've got for you today. Make sure you're feeling okay about these fractions and these problems because we're going to be using some of the stuff we talked about today to help us in our lesson tomorrow on fractions. Thanks so much for watching. Bye.